which points are the furthest away from 1, 0 that are on the ellipse 4x squared plus y squared equal 4? I put most will get it wrong here because that's what all the titles on YouTube seem to say, as if we're all kind of not smart enough to do these problems, although the problems they usually put it on are quite easier. So welcome to Back of the Napkin Math, where we do real math and talk about the elegance of it. The difficulties will range from cute problems in algebra all the way to graduate level mathematics. So if you're into that kind of stuff, please like, subscribe, leave a comment on problems you might want to hear about, and share the videos with your friends. Okay, so this problem is from a calculus textbook, although you certainly do not need calculus to solve it. So the question simply is which points are furthest away from 1, 0 that lie on this ellipse? And I realize my ellipse is not drawn perfectly because I'm more interested in the math than fancy slides. So if you think about this ellipse for a second, when x is 0, you get y squared is equal to 4, which means y is plus or minus 2. So we know we have the points 0, 2, and 0, negative 2. And this point over here is minus 1, 0. And we know that because when y is 0, we could divide by 4, take the square root, we get plus or minus 1. So the question is which points, and there will be two unless this was a circle. If it was a circle, it would just be this point, right? Because that would be the diameter of the circle. But it's not, it's an ellipse. So it's going to lie somewhere on the side of the circle. We're not going to assume that, but we're going to write it that way because that's where it turns out to be. Kind of makes sense that these points over here are closer than these points over here, right? So let's just write our point as x, y for a second. And we want to know the distance, from here to here. Now, if you recall, the distance formula says that d is the square root of the differences of the x's squared plus the differences of the y's squared. And this isn't really terribly difficult to remember if you just think about this as being Pythagoras. Draw a line down here, you have a right triangle. It's just the a squared plus b squared equals c squared, but we've taken the square root. That's all it is. Okay, so what we get is then d is equal to the square root of x minus 1 squared plus y minus 0 squared. And if we simplify this just a little bit, we get d is the square root of x squared minus 2x plus 1 plus y minus 0 squared. Well, that's just y squared. And that's really the key to the problem here, because we know what y squared is from this equation up here. We know that y squared is equal to 4 minus 4x squared. And so what we get then is that our our distance, I'll explain why I slipped and said that here in just a second, is x squared minus 2x plus 1 plus 4 minus 4x squared. Okay, now if you wanted to use calculus, the way you maximize things is you take a derivative and you set it equal to 0. That's why I slipped there. You don't actually need calculus for this problem, and we're going to do it without calculus, but if you wanted to, I'll explain it as we go how you could do it with that. Now let's think about the distance on the ellipse. All these points, they're a certain distance away, right? And one of them up here is the furthest away. One of them down here is the furthest away. If you were to take all of these distances and square them, the one that's furthest away would be the largest square, which allows us to just get rid of the square root. Now, if you're using calculus, the square root really isn't going to matter if you don't get rid of it. It's just going to make things easier if you do. So d squared is x squared minus 2x plus 1 plus 4 minus 4x squared. And now we can combine the like terms, and we get negative 3x squared minus 2x plus 5. And we want to know, when's this the biggest? Well, if you wanted to do it the calculus way, you'd take a derivative. The derivative would be negative 6x minus 2. You'd set it equal to 0, and that would give you the x value. You could check that the derivative is actually going from positive to negative so that it is a maximum. Or if you just think about what is going on here, this the graph of this distance squared function is just an upside down parabola, and so the maximum is going to happen at its vertex. And its vertex, or the vertex of any parabola for that matter, is always given by minus b over 2a. By the way, this also just comes from calculus. Take the derivative of ax squared plus bx plus c, solve it for 0. So let's just use it that way. So we would get x is equal to negative a minus 2 because the x coefficient's the b. And the negative 3 is the a coefficient, so we get 2 times minus 3. And making sure we don't mess up the arithmetic, there are 3 negatives there, so we get negative 1/3 after we cancel the 2's. And so now we know the x coordinate, we just need to figure out the y coordinates because there's going to be 2 of them, and we can see that because we're going to plug in x into here. We're going to have to take a square root, which is going to give us a plus or minus answer. So what we would get then is that y squared is equal to 4 minus 4 times negative 1/3 squared, which is equal to 9 minus 4/9. I messed up, sorry, 4. I was thinking about squaring the 3 prematurely, so it happens. And this gives us 32/9. And so y is plus or minus the square root of 32 over 9, which is 4 root 2 over 3, plus or minus. And so the points that are furthest away are, so the points are minus 1/3, 4 root 2 over 3, and minus 1/3, negative 4 root 2 over 3. And those are the 2 points that are furthest away from 1, 0. And it kind of makes sense that it would be, somewhere up here, right? If you really think about the geometry of it all. But you really can't guess at what the point is. You need to go through these techniques. Now, like I said, this was in a calculus book, so they're expecting you to take a derivative, but you certainly don't need one. If you just remember that the maximum of a quadratic happens at its vertex, or the minimum at its vertex, depending upon whether it opens up or opens down. So just a fun little problem. So some challenges for you guys if you want. Do the same thing and ask what points on the ellipse. So we'll change the 4 to some number. what points on the ellipse ax, I think it's easier probably if we do a squared x plus y squared equal to a squared are the furthest away from 1, 0. See if you can solve it there. A is just a constant. It should match up. When a was 2, we should get the same answer as we got before, where x was negative 1/3. And if you want to generalize it even further, you could ask, what points on the ellipse, and now we're just going to write a general ellipse here, x over a squared plus y over b squared equal to 1, which is the same, by the way. I think it would be easier to see if we write it a different way. Is the same as saying b squared x squared plus a squared y squared is equal to a squared b squared. Our furthest away from the point. Well, what's the generalization here? We're talking about when x is 0. So when x is 0, we get a squared y squared is equal to a squared b squared. The a squareds will cancel. We get y squared is equal to b squared. And so we get y is equal to b. So that would be the top points. And when when y is 0, the a's would, or the b's would cancel, and we'd get x is plus or minus a. So to make this exactly the same, this should be furthest away from the point a0. So try to solve that. Use the same techniques. There's nothing more or less difficult about these problems than the one that we did. It's just more general. So if you follow the same technique, you should get the right answer. Leave your answer in the comments. And tell me what other problems you want to talk about. It could be anything from high school math all the way to graduate mathematics. I'm cool with all of it. And we'll look at kind of fun little things as we go. But I thought this was a nice little problem. And the answers to these general questions are kind of nice. To see what the pattern is and how the point moves along the ellipse as a gets bigger, as b gets bigger, what happens when a equals b, these kind of things. So, all right, well, thank you for watching. Please subscribe, like, and share, and let me know what else you want to talk about.